March 11, 2011, Japan experienced a disaster at the Fukushima Daiichi nuclear power plant where an earthquake and tsunami led to the failure of the plant's cooling system and caused 3 reactor core meltdowns and the release of radioactive materials in the atmosphere and ocean.
Fukushima's explosion was caused by nuclear fission, a reaction in which the nucleus of an atom splits into 2 or more smaller nuclei. The fission process produces gamma photons, releasing a large amount of energy, even by the standards of radioactive decay.
The Fukushima Daiichi power plant worked using nuclear fission by creating electricity as an energy source through the energy produced by the nuclear fission reactions. They harnessed the large amount of energy produced by the large atoms being split and controlled the nuclear fission reactions through control and cooling systems that regulated the flow of neutrons and removed excess heat and collisions to keep the reactor stable.
The incident at Fukushima displayed many of the hazards that come with nuclear fission reactions, such as environmental contamination, waste of nuclear resources, nuclear fission explosions caused by uncontrolled chain reactions, and long-term health impacts caused by radioactive decay. These disadvantages make nuclear fission a dangerous source of energy.
Hear from the locals who've endured the nightmarish aftermath and to see what the future might hold for the area.
However, nuclear fission also provides clean burning energy with low carbon emissions, proving to be advantageous. Nuclear fission reactions allow scientists to generate energy without releasing large amounts of greenhouse gas emissions. It also provides a very high power output and serves as a reliable baseload power source. Additionally, nuclear fission requires relatively small amounts of fuel to produce large amounts of energy and reduces dependency on fossil fuels, helping diversify the energy mix.
Nuclear fission relates to many chemistry topics that we've learned this year. It heavily relates to reactivity. The more reactivity an atomic mass an atom holds, the more an atom is at risk of nuclear fission explosions. Also, nuclear fission reactions relate to exothermic reactions. They release large amounts of energy through chain reactions. The control rods used to manipulate nuclear fission reactions correspond with the speeding up and slowing down of reactions. Using control rods to limit the flow of neutrons is similar to decreasing the temperature of a system in which a reaction is happening, slowing down the reaction. This is part of the kinetic molecular theory.